Hi guys, how you doing? So I'm about to record the walkthrough video on experiment 4. It is extremely short, but I'm going to show you a couple of things that I do when I do these kinds of um, things. So I'm here at the start of this. Oh, sorry, need to share my screen. So I'm here at the start of this, and I'm going to go ahead and start in on experiment 4, so virtual lab 4. And of course, we've got our introductory information, learning about key concepts for this. Part of this is learning the SI base units and the prefixes for each of those. We'll work with the balance in this. We'll work with tearing and how we can handle that, and what some of the easy ways to make that easier for us. So ways we can work with that balance. Okay, so I'm going to go ahead and go into that laboratory simulation. And it says, recall from the introduction that to tear, or zero, a balance means to set the digital reading to 0 before placing a sample on the balance. What would be the benefit of tearing or zeroing the balance with the weighing boat already on top of the balance? And I've got 3 options. The mass of the weighing boat can be easily determined. There is no benefit, or no calculation is needed to determine the mass of the sample added to the weighing boat. And I'm going to say C, because if I've taken and teared that balance after I put the weighing boat on it, what I've done is taken the weighing boat, put it on there, and then teared it. So I've zeroed it again with the weighing boat on it. So I've subtracted out the weight of that weighing boat by doing that. Okay, that gives me an opportunity to then measure only what I've added to the weighing boat. So it makes my math a lot easier. Now I can always do it as a weight by difference. And I can record the mass of the weighing boat, and then I can add stuff to it, and then I can take the difference of those two things. But excuse me. But it's much easier for me to directly take a measurement on that than it is for me to have to do that difference. And I'm sorry, I wasn't sharing my screen appropriately. Sorry about that. So it's easier for me to just do that tear and then take that measurement directly. So that's the first part. Now we'll go ahead and go to the next part. So it says to place the weighing boat on the balance. So I put it on there, 1.471. I go ahead and tear that. And then it's supposed to use the scopula and weigh out approximately 15.3 grams of the sodium. So taking a whole bunch of this, keep going, keep going, keep going. 15.312. Now it's over, and that is perfectly okay. So I record 15.312. When we say approximately, we mean exactly that, approximately. We are not trying to get to exactly that amount. We do not waste that kind of time. Okay. In the lab, all we want to do is get somewhere near what we tried to measure, what we want to measure out. It can be above that, it can be below that, and it does not need to be exact. We do not want to waste a lot of time on this. So we record this number, and that's the number that we take. Okay. So now they want to know the mass of that sodium chloride in milligrams. Now, I love to do this in a spreadsheet because I love my spreadsheets. I'm going to pull this spreadsheet over here, and I'm going to pull the lab over here. So I write down the number that I wrote first, and this is in grams. And this one's going to be in milligrams, and the next one's going to be in kilograms because that's what's in my lab. So when I work with this, I know that there's 1,000 milligrams in a gram. So I need to take this number and multiply it by 1,000 to get the number of milligrams. So I say that equals this number times 1,000. And that's how many milligrams there are. So 15312. When I go to kilograms, I take my base unit and I divide by 1,000. Okay? So I take this number right here and I divide by 1,000. And that gives me this number right here, 0.015312. Okay, now if I didn't know how to do that, I can click into this and it says consider the relationship, all of this wonderful information, and I can screenshot all of this. So I can take my lovely screenshot tool and I can say, okay, I want to do this. And I can't get all of it at once. So I say, I want this part. And I'm going to open my OneNote here and pull this over here. And I want to do my 110 labs and virtual lab 4. And I'm going to put this part in here. And then I need to go back to this lab and I want to do a new one that has this third part in it. So I do a screenshot of this part of it and I copy that. And then I come over here and put that in there. So now I've got all of my calculations for what I needed to do in there. So I can pull that down. I can minimize that. And this is all the math that I did for this. So I have all of that captured. I have all of this done in here. And so now I can maximize this again. And I say, okay, I'm done now. So I hit enter and I go to the next phase. Now I'm completely done. So I'm going to print this. I'm going to print it to PDF. And I'm going to save this. This is what I always do is I come out here and I save this to my Chem 110 folder. And I'm going to put this in my lab folder. And that way, when I come back into here, I can place that printout in here. So I can do an insert, file printout, and then I can go to my Spring 2, Chem 110, lab, and this one, and just insert that printout there. So this is the data that I had. Okay. So this is all the information I did from that laboratory, and it's now stored in here. And that way, when I'm done, after I submit this, and I go to do that post lab, I will have all of that information for that post lab. Okay, so I can go back and do this again if I choose to do so. Okay, now I've done this twice because I felt like doing it twice. So there you go. So that's all the information on that particular experiment. So I'm going to stop this and I will get this posted for you guys. And I will be back with you in a little bit to do Virtual Lab 5. Thanks.